George. Come on. Look at them all.
How you going, guys? Curtis from Cutting Edge Engineering. So today's job is going to be part 2 of the rebuild for our ZX470 arm cylinder. If you missed part 1 where we disassembled the cylinder and did an inspection, there'll be a link in the description below. So today's job, we're going to be making the new barrel. First thing I need to do is get the old one set up in the lathe and pull it apart. So before I start machining the barrel apart, I am going to stamp in my alignment marks and take an overall measurement to make sure when I put this back together, it is exactly the same. I do use the tool center height of the lathe for my alignment marks. That way, as long as I clock them back to the right position, everything's going to go back together as if it was from factory. And I'll also take my overall measurement from the head flange down to the edge of the oil port. It's very critical that you get barrels back to their standard lengths because that's how the machines operate best. And that's one of the reasons why I use a lathe to disassemble a barrel, because I can take all my alignment marks and overall measurements while it's set up. And as I'm pulling the barrel apart, I can also do all of my weld prep so I'm not double handling parts. I find this a lot faster than doing it in a saw and cutting it up and then setting it up and machining it. And Hitachi make it that much easier to do it like this because they do put centers in the end of their barrels. So you saw how easy and quick it was to set this up. Now we can start machining it apart. So that's the barrel end off. It's weld prepped, ready to go onto our new barrel. All I need to do is press out the old bearing, but now I'm going to flip the barrel in the lathe so I can remove the head flange. So before I can remove the head flange, I do have to machine the diameter down. Because they are a cast part, they're not exactly running concentric with the barrel. So in order to hang on to that to bore it, to go onto our new barrel, I'm going to need to turn it true. So this is one of those situations when you can get yourself into trouble, because I am about to machine away my alignment marks. So I'm just going to put a center pot mark in the face of the head flange so I don't lose my marks on the outside of the flange that correspond with the end of the barrel. So I've got the head flange off. I'm going to get the old barrel out of the lathe so I can set up the head flange and bore out the ID. Right, so we've got the ID of the head flange bored to size. Now what I need to do is set up the new barrel so we can turn down the OD for the head flange. Pretty funny. Yeah, hold on. So the piece of material we're going to be using for our new barrel, it is hone tube. It has 190mm ID by 230 OD. It is the exact spec size for this cylinder. So there's not much machining we need to do to this. First thing I'm going to do is machine down this end for the head flange. So now that's machined, we can get this out of the lathe and fit the head flange. So a head flange does have a 0.2 interference fit, or about 1/8 thou. So we're going to need to preheat this in order to get the head flange to expand, so we can then drop it over the barrel. When it cools down, it's going to shrink onto the barrel, and it's going to be a very nice tight fit. So the reason I do make them an interference fit and it is so tight is because you don't want any air gap around the head flange to the barrel. If there is an air gap there, because the barrel is so thin, you can end up with cracking from the inside. So the tighter you make it to hold everything in place, the longer this cylinder is going to last. So that worked out really well. That went about as perfectly as you could hope it to. When I'm fitting head flanges, if something goes wrong, you don't have a great deal of time to try and fix it or rectify it. I do have a hammer at the ready in case the head flange stops halfway down. You probably notice how quick the heat dispersed from the head flange into the barrel, and it grabbed a hold of it. That's exactly how we wanted it to go. So now with that fitted, let's take it over to the welding area and weld it on. So to weld the head flange onto the barrel, I'm going to be using CIG Verticore 3XP in a 1.2. I'll be backing that up with Argo Shield Heavy, which is 80% argon, 20% CO2. I'll be running that at 27 volts and 6.5 meters of wire a minute. So to fill this joint, it's going to take about 10 layers of weld and about half an hour in time. So the welding's done on the head flange. I'm going to have to let that cool down for a while. Even though this is honed tube, that heat affected zone is going to shrink, so that area will need to be honed back to spec. While we're waiting for the head flange to cool down, we're going to press the bush out of our barrel end and sandblast it, ready to go back on the new barrel. No cracks in the bushes. Alright, so that took about 20 minutes. Not all the paint is off. It does take quite a long time in a sandblaster like this. This isn't really an industrial unit. This is more for your home hobbyist. Hopefully one day I will invest in something a little bit bigger to make this sort of stuff a lot faster. So this is cooled down enough now, we're going to get it set back up in the lathe. Now with that done, I'm going to flip the barrel and get the other end prepped, then I can fit the barrel end. So you may have noticed when I removed the barrel end that there is a big hole in there. Well, that hole actually corresponds with the rod. So that is the choke for the closed cycle of the cylinder. On the rod there is some silicon bronze, which is a sacrificial material. So if it does collide with the barrel end, it will just deform, but it does stay in place and doesn't end up through the entire hydraulic system. So now I've got the barrel end tacked in place, I'm going to take it out of the lathe and go and weld it. So now I've got that end welded, I'm going to let that cool down for a little bit, then we're going to set it up in the honing machine.
What? Come on then. Let's go. Hey? What can you smell? Righto, so we've got our barrel set up for honing. Because this is a honed tube and it is honed to size, I'm only going to be working on the heat affected zone and going to bring that back to size. So we're going to use our bore gauge to take a measurement of the tube, and then we're going to measure the heat affected zone to show you how much it has shrunk. So our bore gauge has showed us that the heat affected zone has shrunk 0.4 of a mil, so that's about 16 thou. That's just how much things shrink once you weld them. But it is only in about a 70 mil area, so that is the area we're going to concentrate on and bring that back to size. I don't need to hone the very end of the barrel where I've welded on the barrel end. Because of the way the Hitachi cylinders are designed, the piston never gets that deep into the barrel. There is a nut there that stops it getting to the heat affected zone, so the piston will never ever interfere with that tight spot. So when honing a barrel that has a heat affected zone, but the rest of the barrel is all ready to size, you do need to be extremely careful that you don't overcut either side of the heat affected zone. So being careful means do a couple of cycles, pull the hone head out and measure it and make sure you aren't overcutting either side. And you pretty much have to do that for the whole process until you get a nice even measurement all the way through that heat affected zone. Not only do you need to take measurements, you do need to check your stones. If the stone is wearing the middle and not the outsides, you do need to take them out and put in a new set, or you can file the stones flat and continue honing. Right, so I've worked out the tight spot in the weld zone. I still have a bit of a tight area where I heat shrunk on the head flange. So I'm going to extend the stroke length of the machine so I can now bring it all back to size and take out any other tight areas. Righto, so we've pretty much got that bang on size. We are 0.01 of a mil off our finished dimension. So now I'm going to change out our roughing stones to our finishing stones. I will also extend the stroke length of the machine so I can blend in the area I have honed into the existing material.
Looks mint.
Righto guys, so our barrel is now rebuilt. I have given it a clean and sprayed in some rust preventative and wrapped the end up because we do get flash rust in here and I don't want to create any extra work for myself. So now that that's done, I'm going to put this to the side. I still need to make the new piston, but you'll have to stay tuned for the next video where I machine that and get this cylinder reassembled. Thanks for watching.
Just do a retake, so then I've got one take.
Right, you ready?
I am, yeah.
Wait, how'd you start it?
I didn't. You did.
What did I say?
I don't know.
So before I start machining the barrel apart, is that right? Yeah, that's right. Righto, so I've worked out the tight spot in the weld zone. I am going to increase the length. Oh, fuck me. So I've worked out the tight spot in the heat effect. Oh, fuck. So I've honed out that tight spot. Everything's sort of. Oh, fuck.
Oh my god, nah.
Now we can. Oh, fuck. What'd you say? So, what's next? Fuck off, train. Right. Ready?
Yeah.
So, where'd you start from? Wrap swarf in swarf.
Yeah. That was crazy.
That's the shit.
Whoa, that's gonna touch the bottom, huh? Is that tool height wrong? Ah, there we go.
You are correct.
Do I get back?
No, fine. Right. Yep. Just stand there, it's fine.
Okay.
What's wrong, boy? Oh, you son of a. The fucking arm fell off.
Oh my god. Is that a little plane?
Got those fucking paragliders again. That one's got wheels.
Wow. What the hell? Is that like a go-kart?
Like a go-kart with a fan on it. Or a fucking plastic bag. Shop made Q-tip.
Shop mate.
Not sponsored.
If everyone wants a video on how we make one of these.
How else do you get in there to clean the barrel?
I have no idea.
That's perfect. It reaches all the way to the end. It's lightweight. You can change the rags out. It's perfect. Spot on.